In this video, I'm going to go through the notes for both 10.6 and 10.7. We're going to cover notes on 10.6 Friday the 20th, and then Monday we'll do notes on 10.7. In section 10.6, we look at other types of angles in circles. So far, we've talked about inscribed angles, and we've talked about central angles. Now we're going to look at how to find the measures of other types of angles in a circle. So the first one is when we have angles inside the circle. So you've got the measure of angle EDF. Okay, that's this angle right here. Well, I know that's going to be congruent to that angle because they're vertical angles. So it's got to be equal to the measure of angle GDH. Now, the way we find these angles is not just the same as the arc or just half of the arc. We've got to look at two arcs when we find this measure. I'm going to take half of the sum of two arcs. So if I'm looking at angle EDF, I want to see what arcs are between that. You've got this one, and then on the vertical angle, you have this one. So I've got to look at those two arcs, and I'm going to find the sum of those. So I'm going to do the sum, I'm going to do half the sum of the measure of arc EF plus the measure of arc HG. Now, if I wanted to find one of the other angles, once I found this angle, I could subtract it from 180 to get this angle. I could, if I found this angle, I could subtract it from 180 to get this angle. So if they're ultimately asking for the other two angles, so you've got angle EDH, which is going to be the same as angle FDG. I'm going to take the sum of this arc plus this arc and divide it by 2. So half of EH plus FG, whatever their arc measures are. The next problem we've actually talked about, but I'm just giving you essentially more details on this. I guess you could say like a rule. This one I'm dealing with a tangent and a chord. So in this case, the first problem, measure of angle JKM. Remember we talked about essentially because the vertex is on the circle, that's still an inscribed angle. So you want to look at what arc matches with that. That's the arc that goes with that angle. So it is going to be equal to half the measure of arc MK. And if I look at this angle and I follow that, it goes from the vertex all the way around. So it's going to be half of the measure of arc MNK. So you've got a major arc there. Okay, the next three, if you notice, the angles are not inside the circle anymore. In these cases, the angles are outside. When it's inside, we take half of the sum. When the angle is outside, you're going to take, instead of half of the sum, you're going to take half of the difference. So I take the two arcs that angle intersects, and I'm going to do half of the difference of those two arc measures. You just want to follow your angle all the way through the circle to find out what arcs it's intersecting. The next one, when I'm dealing with angle G, I've got a secant and a tangent. If I follow the arcs, you've got this arc and this arc. So I'm going to take half of the difference between arc IF minus arc HF. You're always doing bigger minus smaller. Otherwise you'd get a negative, and you can't have a negative angle measure. And on the last one, I'm dealing with two tangents. So if we follow where those tangents hit the circle, you're going to take half of the difference between this arc and this arc, which if you notice, both of those arcs together make up the entire circle. So half of the major arc MPN minus the minor arc MN. Now we're going to work on lots of practice in class and for homework, and then we will cover 10.7 on Monday. I'm going to go ahead and go through the notes for 10.7 in this video just to have everything all in one video. In 10.7, instead of looking at the angles, we're going to look at segment measures and how we can find various segments. We have rules for each of those. The first one, we've got two chords intersecting, and there is a special relationship between those. If you've got that chord and you've got that chord. What I'm going to end up doing is multiplying the parts of each chord by each other. So RQ times QT, whatever their lengths are. So you've got RQ times RT has to be equal to the measure of SQ times QP. Typically you're going to have one piece missing. Sometimes you might have more than one piece missing. Remember, I mentioned in class that you're going to be taking these rules and applying them to different types of problems, which are almost like puzzles, trying to see how am I going to use that rule in this problem? What do I have to use to solve the missing piece? In the next picture, we have two secants and how we can find various angle measures. So you've got the outside piece of this secant, and then you have the piece that meets on the other side. You also over here have this piece, and then you follow it all the way in. So if I take the measure of WV, which is the piece on the outside, and I multiply it by the whole thing where it stops on the other side of the circle, which is WY, that has to equal the measure of WX, which is the other secant piece that's on the outside, times that whole piece, WZ. And on the last picture, we have a tangent and a secant. So this is my tangent. If you think about it, you've been multiplying two things together. Well, on a tangent, you're only going to have one part. You just have the outside part. We're going to square that piece on one side. And then on the secant, I'm going to do just what I did before. I'm going to take the piece on the outside, and it gets multiplied by the whole thing. So that would be BC times BD, what the whole thing is. Now remember, if this is X and this is 4, then the outside would be X and the inside would be X plus 4, because you have to add those together to get the whole thing. We're going to have some problems like this, as you'll see on the practice that we're going to do. And that is it. Make sure if you do your homework, you do the practice, you still have questions, come to tutorial and get help.